Hello, today we'll be solving a bi-weekly contest that is 68. I'll be giving the virtual contest and I'll be trying to solve as many questions as from right here live. And yeah, let's see. And mind you, I might not be able to solve some, or I might be able to solve everything. So this is just a practice uh, and nothing to be expected round, we can say. I just want to do as many problems as I can. So yeah, that is it. I'll be sharing the experience. Okay, why is it not loading? I don't know, for some reason it's just not loading. Okay, there it goes. Starting from one right here. Let's see, one. Maximum number of words found in sentence. Okay, it is recording. Okay, let's do this. Maximum number of words found in sentences. A sentence is a list of words that is separated by, okay, you are given an array of strings, sentences, where each sentence of I represents a single sentence. Return the maximum words that appear in a single sentence. You are given an array of strings, sentences, okay. I'll be given an array of sentences. Where a sentence of I represents a single sentence, return the maximum number of words that appear in a single sentence. Okay, so the maximum number of words that are appearing here. Okay, continue to 5, continue to win. Okay, so I'll be just taking in the words from here. That will be my sentences. There are formed sentences dot length and I consist of lowercase and does not have any leading or trailing spaces. That is good. All the words in sentences are separated by single space. Okay, cool. So what I think of here is I'll just simply iterate over the array. Okay, iterate over the array and find out find out the length. And yes, that should be enough. So let's just start. So for in I, let's just say auto I in sentences and for auto C in I'll check for the number of spaces that I've got. So if the C is equals to a blank space, that means there is some word right there. So if there is a word, I'll just increment my count by one, and the count is initialized here. That is, count is equals to 0. And after I'm done doing that, I'll just store this in a maxi variable, which will store my overall maximum count that I have got right here. And this should give me the correct output. And let's just initialize maxi as well. Maxi is initialized to int underscore min. Since I'm finding the max, I will initialize it as a very small value. So let's see what we have got here. Let's try run this code. Alice and Bob love Leetcode. If I have this right here, Alice and Bob. So it will take out the string right here, first array element, and it will go on checking. It will find for a space. Since it finds a space, it will increment the counter by one right here. Increment the counter by one, and it will move on. Again, it will go on. If it finds a space, move on. Yeah, this seems fine. Okay, okay. I should have not deleted this. Just need to delete this guy right here. Okay. So let's see. It's fine. Let's run this. Okay. Yep. Let's see. Answer is 12. Whereas it should have been 6. Why? Why? Okay. I'm not initializing the count equals to 0 here. So it is taking the overall value and it is carrying the value of count forward. So that should not have been done. Okay. So this should work. It's taking so much time. 5 why? 1, 2, 3, 4. Okay. 1, 2, 3. Okay. 1, 2, 3, 4, 5. Yes, it is indeed 5. Why is it giving 6 here? Let's see. Here has 5 words in total. Okay. The sentence, I think, 1, 2, 3, 4, 5. Okay. 5 words. Second, the third sentence has 6 words in total. 1, 2, 3, 4, 5. Okay, I got it. I got it. So the last space I'm not counting, so it will always be maxi plus one, always. So let's say even if there is one word, something like this. So this, it will not find the space. So I will indeed have at least one element every time, right? That is why plus one. And yeah, this should work. Yeah, let's run the cases. I'll move on to the second one as well. Let's open this and 6 and 3. Okay, works fine. Submit this. Move on to the next question. Okay, find all possible recipes from given supplies. Okay, let's see this first. Okay, accepted. Let's move on. Find all possible recipes from given supplies. Let's see. You have information about n different recipes. Okay, cool. You're given a string array recipes. You have an information about n different recipes. Okay. You have been given a string array recipes. I've been given the string array recipes. Okay. And a 2D string array ingredients. Okay. Ingredients. I've been given this as well. The ith recipe has the name recipes of I. Okay. This guy has a name. Cool. Okay. So this guy has a recipe name. Okay, and you can create it if you have all the needed ingredients from ingredients I. Okay, ingredients to a recipe may need to be created from other recipes. Okay, that is ingredients of I may contain a string that is in the recipes. You're also given a string array supplies containing all the ingredients that you have initially, and you have an infinite supply of them. Return list of all the recipes that you can create. You may return the answer in any order. Note that two recipes may contain each other in ingredients. Let's see. Let's understand from this. I did not get the question quite. I'll read this again. So you have information about n different recipes. Okay, you are given a string array recipes, that is this guy right here, and a 2D string array ingredients. Cool. The ith recipe has the name recipe of I. Okay, and you can create it. Okay, I want to create this bread here. Okay, okay, cool, cool, cool. If you have all the needed ingredients from ingredients of I, if I have all the ingredients that is needed, so if I need to create wheat or bread, I need yeast. Need yeast, flour as well. If you have all the needed ingredients from ingredients of I, okay, ingredients to a recipe may need to be created from other recipe. Okay, that is ingredients of I may contain a string that is in the recipe. Okay, I can also have this guy here. You're also given a string array supplies containing all the ingredients that you initially have. I have these guys at first. Okay, You're also given a string supplies containing all the ingredients that you initially have, and you have an infinite supply of all of them. List of recipes that you can create in and return the answer in any order. Okay, so if I need to create bread, I will need these two things, and I indeed have these, so I can create this. I'll answer bread and sandwich. Okay, so for bread and sandwich, for bread I need yeast and flour, and for this sandwich I need bread and meat. Okay, and the supplies are yeast, flour, and what? Meat. Oh, nice. Yeast, flour, and meat. So I can create bread, obviously. And let's see. Yeast and flour have been met. Okay. The recipes are what? Bread and meat. Supplies are only meat. I also need bread. We can create bread since we have yeast and flour. Yes, we can. Since we have this, I can create this bread. And create sandwich since we have ingredient meat and okay, cool. Okay, I get it. Bread and okay, again this thing. Again that thing, yeast and flour. Okay. Create bread since we have ingredients yeast and flour. I need to create sandwich. For sandwich I need bread and meat. Bread can be created from this, even if I don't have the supply. Okay, so this guy creates bread again. So bread and meat. Sandwich is made. The sandwich is made. Burger. Burger needs what? Sandwich, which has been again met. Meat, again I have it. Bread, again I can make it. So all the three can be made. Okay, so let's see what we can do here. Recipes dot length n is 100. Okay, ingredients I and supplies length is 100. Recipes of I dot length and ingredients ij length less than or equals to 10. Recipes of I consist of only the lowercase and all the values of recipes and supplies combined are unique. Ingredient side does not contain any duplicate values. Okay, so not have any duplicate values as well. Let's see what I can do. I have bread, yeast, and flour. Okay, let's say if I have bread, yeast, and flour, and what are the supply? These are the ingredients that I need, and these are the supplies that I need. First of all, if I want to create a bread, I'll go into the recipes guy. Okay, I'll check for what are the ingredients that I need for this guy. I know I need these two right here, and I need to find these two things in this supplies. Okay, so if this condition is met, I am able to make this thing always. Yes. So this can be made. This goes into my answer. Bread goes into the answer. And also when I am able to make this, this also goes into the supply because I am able to make this, right? Yes, surely. So now comes bread and sandwich. Bread was needing these two things, which I already have here. So I can make this, and this bread also goes into the supplies. Yes. And for this thing, for making a sandwich, I need bread and meat. So bread and meat. Meat I already have. And bread I also have it since I've already made it using yeast and flour. So I can indeed take that. Yes. And since I'm already having the values as non-duplicate, which is written here, so I can contain it into a set. I can indeed contain it into a set. Ingredients of I does not contain it. Okay, so my flow would be uh, Go through the recipes array. Go through the recipes array. Okay. Check out what it needs in the ingredients array. Cool, cool. And the supplies, whatever you have. Supplies, whatever you have. Store these things into a set, into a container. So when I need this thing, I'll just check into the container. Do I have it or not? Again, when I need this, I'll just check in. Do I have it or not? If I have it, I'll be able to do it, and I'll push this into an answer. So my intuition is to basically go over this again. Go over this ingredients. Check for the supplies. If it is met, put it into the answer, and if that conditions are met, I've put it into my answer. Also put this into the supplies since I am able to make it. So yes, that will be the intuition behind this. Let's see if this is recording or not. Yes, it is. Okay, I need to return a vector of string. Cool. So let's create a vector of string as my answer first. Answer. Cool. And I also be or dered unordered. Set should suffice. Yes. Should suffice. String. Let's call this S as well. Okay. Recipes, ingredients, and supplies. Right. Okay. Let's just call this R. These huge names I have to write. And supplies. Let's say SS. Cool. What do you have to do? I'll just have to iterate over. And this is just a for each loop that I'm writing here for auto I. If you don't know, you can just Google it, you'll get it, how it works. It just basically traverses. So for auto I in my recipes, I'll go in the recipes to check for, and then I'll go and again I'm having a vector of string, right? For ingredients. This is what I need to handle for. Okay, let's not take a auto of IR. Let's just say uh, the classic while loop that we write. Let's take the int rxz, that is the recipe size, r dot data size, int ingredients dot size is isz, I dot size sizd. Okay, and ss dot size. Will I be needing that? Wait a minute. So all the supplies that I have, I want those things in my set. Let's just put it into a set. Auto INSS is dot insert the I. So this is being taken care of. Let's just put on there. Okay. Now what do I know? I want to go through the recipes. So R I plus plus, not R. R is set. Int j is equals to 0. Let's see. Do I need to go for j is equals to 0? Always. Is it? No, I do not. I need to go for this guy right here. Ingredients. Okay, ingredients is having I value, right? I cannot take this then. Let's say A. So A, ingredients of A. Okay, and G is less than whatever the value of that guy is and the size. That means IA dot size and J plus plus. This should not be A. This should be no. It should be A. It is fine. It is fine. It is fine. Let's see what I can do here. Now I am going through the recipes of that guy and I am iterating over this guy right here. Ingredients. I'm in this bread and I am iterating over this. And let's see if all the conditions are met. If all the conditions are met, so I'll see if let's just find it into the set. So if s dot find s dot find I of I of mm, j I of a and I of a dot size I plus plus j is pointing to a of I, that is this guy right here, j of 0 that is pointing to here, and so I've got this one right here, and j is pointing to that, j less than that size. But do I need this? Since I'll be having that from there, right? So why do I need IA? Well, I need IA. It will always be starting from there, right? And this is the size. So I of j that I've got from there, it specifies that if s dot find is not equals to is equals to s dot end, that means I did not find it, and I'll just simply say mm, I can say a flag is equals to false. Flag is equals to false. I did not find it. And let's take a bool flag is equals to true every time. Every time. If it does not find, and if we get out of the loop and see if flag is indeed true, that means yes, I've got that. So I'll just push this guy right in answer to pushback. I'll just say that recipe guy can be indeed my answer, can be my possible answer. I just do this, and flag is equals to 1. I can just simply break out of the loop as well. So this seems fine. I of j, I of j, I is there, I is there as well. Okay, and we can just return the answer as well. Okay, so let's just dry run this once and maybe can get a better hold of this, if it is working or not. I'll just copy this thing here and here as well. Okay, let's see. So I'm at the 0th guy. I'm at this bread thing right now. I'm here. I'll go for I of A. I of A means I of A, this guy. So I of 0 is pointing to this guy right here. So now I'll start from j is equals to 0, that means yeast. I'll see if I dot find I of j. I of j is pointing to this guy right here, yeast. If I find it, yes, indeed I find it, since I have it here in my supplies. So I will not go inside this. Again, I'll find for flour. I do not find it, and this is the end. So I'll go out, and if it is indeed true, I'll push it in. Similarly, okay, I missed one point also. So if I do it, I do need to push it into my supplies, right? Push back. Oh, no, no, no. It should have been not push back, s dot insert, since I'm pushing my supplies into my yeah, right, the set, an ordered set that we had created. So the recipes of a is indeed my new uh, supply that is possible right now. This is also added. Yes. So now when I go for sandwich, I'll check for this guy right here, a dot size, that is indeed 1. So I'll go for this bread and meat thing. So I'll just check on for bread and meat if it is possible to create or not. Bread has been created since I inserted this guy, right? I did indeed. Previously when I had this, I just created this bread as well, and I also have this. Okay, now this should work fine. This should work fine. Hope this works fine. Think so. Call to find no matching member function. Interesting. Not interesting. If I of j, okay, I and j, sorry, it should not have been ing. 0 1 ing. So the zeroth guy and the column should have been a. Column should have been a. Since when I'm at this guy right here, let's see. When I'm at this guy, yeast, it is 0 0, right? It is 0 0. Then I move on to the next row, that is 1 0. So yeah, now this should work. JA, yes, now that was okay. Now why is it giving me runtime error? Heap buffer overflow. Okay, not cool. Let's have it. What is my I of j being given? Let's see. See out. Is it giving a runtime error? Yeast. Perfect. Perfect. Okay. Why is it not going to the flower part? Let's see. 0 0 0 1. 0th row, first column. 0th row, first push. It should just have been the opposite thing. I missed out that. Now this should work. See out. Let's see. Again a runtime error. Yeast and flour. Okay, now it is accessing at least. That is not a problem. Now what is the problem? Yeast, flour, and corn. Let's see. If I start find this guy right here, string answer ss. I'm inserting in the supplies, inserting all the values in s. Okay, rs set through the supplies, through the recipes, and this guy says is z. That means I of a dot size. Ingredients of a dot size. Ingredients of 0 dot size, 1 dot size. Yes, that is fine. J plus plus. Okay, that is also good. Now it will go on to what? The 0 0 first, 0 0 first, 0 1 1 0 for in the next one. Should have been something like this: 0 0, then 0 1, then 1 0, then 1 1, 0 0, 0 1, 0 0, and 0 1. So ing, let's see, j is 0. This is also 0 0 0. Then 1 0. I'm just going on to the next column. Should it be that? I'm just going on to the next row at once. That should not be the case. It should have been a j. Since I'm going through the columns, let's see, a dot size, right, which is 2, which is 2. So 0 0 0 1 should not be causing a problem. 0 0 0 1 0 0, this one will be 1 0 and 1 1. Fine. When I come here, what do I see? This guy is of size 3, right? So 0 0 0 1 2 2 0 2 1 2 2. So as e moves on. Since I have bread here, I'll go through the whole thing once. this whole thing once. When I'm here, I will go through this guy. This guy. I should go for this guy. 0 and I of a dot size. I of 1 dot size. Surely should go there. And J plus plus. Okay, that is also fine. A and J is equals to S dot n. That means I do not find it. Flag is equals to false and break out of the loop. That means I break out of this loop, and if flag is equals to true, flag is equals to true still, so push it into my answer and push this into the as well recipe in the answer and also into the set. So what is the problem here? String answer. I'm getting a runtime error for what? For what? Okay, cool. Now it's working. That is what I thought. It should not have been giving me a runtime error since I changed the condition as well. Okay, now it's working. Let's check the bread sandwich, burger. Okay, cool. It should work. What's the time left? Let's see. Oh shit, that's 58 minutes. I wasted a lot of time. This should get accepted. Oh no. Why not? Has the contest been over? No, it is not. Okay. And this is the correct one, and this should be in this. What is the problem here then? This one's matching, I is matching. Is this IZ CAD here? IZ CAD is not here in the answer. So, okay, the test case. This is a problem. XPQ, BZ, this one is matching, this 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 is also matching. This right here, where is it? Okay, this one is also expected, but I do not have this. Okay, let's see. IZCAD. IZCAD. To make this IZCAD, I need these things. I need these ingredients. Let's see this case that we have been given here. Where is the supply? Okay. It should have been somewhere here. Where is the bracket that's sending? Okay, it's sending here. So OTR WP. What was I needing to create this? OTR FZR and Z. OTR FZR. I do not have a Z here. How can that be a possible answer? When I create this, I only need this WBJR, which is indeed in my array. So I will be able to create it. Now, okay. So is it the case that we can shuffle also? Let's see. Recipes.length and 100 supplies 100. Okay. So should I just sort this thing right here in the order of their sizes? If I do it in the basis of order of sizes, then No, 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 no. That is not possible. Since I'll be messing up the recipes and ingredients, what I need. So, what shall I do? First of all, let's just copy this right here. Oh, no. What did I just do? Page not found. Okay, just go back. Okay, go back. Okay, that is that wrong answer page. I need that. What is the time left? Oh no, 54 minutes. Should be open. Check if a parenthesis string can be valid. Okay, internet is working fine. What is the problem now? Yes, it's on the cases. Was it copied? No, it was not copied. 54 minutes. Let's see. Let's submit this again and check for that test case. Here, this test case right here. Right. This is the problem. Hmm. Your answer expected answer. XIJ. Okay, IZCAD is not here. So make this. I need this thing and which is present. So now I will be having this thing also and this thing also. This thing in my set. To make this thing, I need these three things: OTR, FZR, and G. I do not have this. I do not have this right now. Hmm, okay, let's see. Let's check for Z. 1, 2, 3, 4, 5. To make G, what do I need? 1, 2, 3, 4, 5. Need these things: OTR, FZR, and XGP and WBGR. Do I have XGP, WGR, OTR, FZR? Okay, I do indeed have it. Should I start my iteration from the back or what? Since I need all those things, what should I do? What would be the best possible way to do? Mm, choosing what I already have. If I choose what I already have, if I choose those recipes which I have the ingredients for, then I will also be having everything. So go on for every recipes which I have the ingredients for. Can I do that as well? Or should I just traverse it once more? Should I just traverse it once more and get it? It will be just increasing the time complexity. Should I just traverse this once more? If I just traverse this once more, let's say fs dot find a of g, then I'll also have to find the recipes in the array. If I do have the recipes, I do not need to move again. I'll just traverse this once more. Let's see. If I traverse this once more, I'll check for if AJ is present there, and if it is ending, then break out and if I start find the recipe that I have here, that is a not a of r of a, which is already present in the set, not equals to s dot, and then also break out of the loop. Can this work? Let's see. Okay, my answer will be the repetition of this, everything. Because now I do get izcad. I do get this thing right. Shall I just traverse from the back and see? I should just traverse from the back, I think. What will be the greedy choice do I make sure? Pick up all the guys who are having lesser needing variables on lesser needing supplies. You can do that. I also need to solve. Okay, 49 minutes, very less. Let's see. For G, just travels from back and hope for the best. Z minus 1 is greater than or equals to 0. Then I'll just check for proving the thing. Okay, if we can prove that indeed traveling from the back is a good option, I'll prove that later, but let's just first check out what is it. Is it cat? Is it matching? H T H Y H T H Y. Was it in my answer array? Press the lens, just check it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Again, I'm missing something right here. I have this guy right here. I have B, G, Z. Now I do not have this T, O, K, F, E, K, F, Q. This is a problem. What should I do? Let's see. Traversing once from the back and once from the front. Once from the back and once from the front. Mm, Traversing once from the back. I'll just make the safer choice, that is once from the back and once from the front. Check if this suffices. If flag is true, then push back this thing. Find is not equals to s.end. If these two guys are true. Okay, I'm getting repetitive many characters. Let's see how we can avoid that. I'm inserting it every time. Find is not equals to s.end. I'm trying to find in that thing in the ingredient. Do we have that ingredient to make? If I do not have that ingredient to make, and why should this be and? If I do not have this ingredient, or if I have already made this, why should I make it again? So then it should have been false. This should give me the correct answer. I just traverse from the back and front as well. Let's just see. XV IZ BX IHV. Okay, HV, where is it? HV. Okay, this one's TOC. Okay, Z GVH. Okay, cool. I did not come up with a proof, but it works fine, so we just submit this. It should give a wrong answer. Oh, getting too many wrong answers. What is it? What am I repeating here? This. Oh no. Expected is this and my output is this guy. Well, that is a blunder. I'm at a rating from the last first. I'm at a rating from the last first. Okay, that's the time. 44 minutes. The reading from the last and reading from the first. Shall I do the opposite thing and check as well? Shall I do this? So if I just read from the first, let's just add this condition here also and check for the previous output first. Is it giving me the correct answer? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. Now let's check on for this thing. Why is it not giving a correct answer? Okay, now it has reduced one gain. This is a problem. So doing it twice is also not working. What can I do more? What is it? Okay. So what is the time? Let's see. 43 minutes. I'll start the question. Okay. I'll start one more. Just try to debug this for more 5 minutes, and if it I'll try it for 3 more minutes, and I'll just move on to the next question if it doesn't work. Bread needs yeast and flour. Sandwich meat. Okay. What is the best possible configuration that I can do? I can try all those guys' recipes which are indeed possible to make. Which are indeed possible to make. So make those guys now. And after that, when you have made those guys, do not traverse for those. Try to traverse for those guys which are not made. Why not keep a visited array? Can I? Let's see, a visited of what is the size of RSZ, right? And just man set this guy, right? Visited comma to 0. Size of visited. But from the first, it is done. Should I do it from the first? If I do it from the first, I'm missing out on some variables. If I start from that, I'm missing out on some variables. Okay, let's just start from that. Okay, and let's just start from the first again. Why not just start from the first again? Might have missed someone. I might not have missed someone. Let's just see if visited of a is equals to 0. That means it has not been visited. Then only do this. Otherwise, don't do this. Then only do this. Otherwise, don't do this. And if flag is equals to true, let's see if this guy is here. Why should I put this here? Okay. Flag is equals to true. If visited of E is equals to 0, that means it has not been visited previously. So I'll go inside this. But let's say if it has already been visited, then what will be the case? Then flag will always be true, right? And it will again try to push it in, which is not the ideal case. So for this guy, let's just put it inside this if as well. So now this should, if it has been visited, now it should give me an answer. Okay, nah, again some weird thing, again a wrong answer. Okay, I should move on to the next question, otherwise I won't be able to try all the questions at least. Okay, open up. Check if a parentheses string can be valid. Parentheses string is a non-empty string consisting only of opening brace, closing brace. It is valid if any of the following condition is true. It is opening, closing. It can be written as AB, E concatenated with V, where AB are valid parentheses. It can be written as A, where A is a valid parentheses. You are given a parentheses string and a string locked okay, both of length n. Okay, locked is a binary string consisting of zeros and ones for each index I of locked. Each index I of locked. If locked of I is 1, you cannot change s of I. If locked of I is 1, you cannot change s of I. But if locked of I is 0, you can change s of I to either opening or closing. Return true if you can make s a valid parenthesis, otherwise return false. Okay. Let's see what are the constraints. 10 to the power 5. S of I is either this or this. Okay. Close, close, close. It can be made. Let's see how. Locked of 1 is equals to 1. This guy is 1. Locked of 3 is indeed 1, so we cannot change 1 and 3. So we can change 0, 1, 2, 3 and 4 to this is this, and while making it unchanged. Let's see, index 0, 1, 2, 3, 4, 5. Well, if I have this guy right here, I can either make a change to it or I cannot make a change to it. I can either make a change to it or I cannot either make a change to it. That is my wish. So here I can either put it some way, something like this. I can do a change and put it, and this guy cannot be changed. So I have already processed. Go on to this guy. Now this is already a opening brace. Do I need to change it if I already have a closing brace? No, this will, if I change it, it will make it invalid. So this and this is processed. I have this guy and this guy, and I have the value as 0 and 0. So I can make a change to this and put it something like this, and this will be a valid string. Okay, so I have multiple indexes where I can either make a change or I cannot make a change, and the value is 10 to the power 5. S. What is the length of S? The length of 5, right? Locked is also having this. Let's see. What can I do? I have multiple indexes and I can make change to multiple indexes if I want to, and I also can omit it. So if I go on here, I can either make this change or also cannot make this change. I can make this one. Can I do a recursion on this? Probably I can do a recursion, because why I'm thinking of recursion is because I have multiple choices. Like I also can change this or not, and I also can change this or not. If I'm just simply iterating over, I wouldn't have the possibility of having this changed or this changed, and I cannot check if the next guy to me. Okay, so there are multiple possibilities. So, what do you think? Can I? Let's see. Let's write this down. Something like this. And if I have a possibility of changing it, I can either do two things. I can either change it or not change it. So let's just say I want to change it or I want to not change it. If I want to change it, my string will become something like this, and I'll continue over with something like this, right? And now I'm at this index right now. So after that, I see what is the value right here. So it is 1. So I know I cannot change this. So I'll just move on to the next index. That is this guy right here. I have an option either to change or not to change this guy. But first of all, I'll have to check the preceding guy or the next guy. Is it already a closing brace? Is it already closing brace? I'll have to check this. Okay, can I have something like uh, double double this thing? Can I have it a bracket inside a bracket? Can I? Is there a test case? If concatenated with v. Okay, no. I do not have to take care of that cases. So just need to check on the preceding guy. I can either have something like this, or this, right? Like it's given here. So at last, my answer should be just an opening and a closing, not multiple enclosings inside another, not multiple uh, excluding bracket inside some bracket. So if this guy and this guy is similar, so why cannot I just move to the I plus 2th index and again check for this? Can I do this? Can I? Oh, I think I can. I can. 30 minutes. Okay, let's just open on this right now. And I'll just read this thing. I'll solve this. Okay. Can I do recursion on this? Possibly you can. But what if there is already a solved string that is given? This and this. Mm, so if I already have a solved value and I also have many options, I'll just check this and this. It is equal. Not a problem. Move to the I plus 2th index, that is this one. Move to the I plus 2th index out of bounds. Now return 0 or return true. Return true. Should I do a recursive way or should I implement a stack way? Let's see. If I try to take a stack right here, if I just put in this guy, I can either put in this or I can put in either this. But let's say if I maintain a stack at every point, maintain a stack, if I carry over a stack, I can say if I have a 0 here, I can put into my stack this guy right here or this guy right here and call for the next value, isn't it? Now after I have completed the whole thing, I will go on for a check of valid parentheses check, that is it possible to do it or not. If it is indeed possible to do it, I'll try to do that. I think carrying over a stack should be fine. Carrying over a stack is what I'm thinking of. 29. Carrying over a stack. This is what I have. Okay, let's go through this. So what do you have? These inputs. Let's create a function f which will be having my string as well, and I'll also be carrying a stack, okay, and index as well, obviously. I okay, call for this. I check the value if it is changeable or not. If it is changeable, I can either do two things, either pick or not pick. Sorry, either change or not change. So let's say I change the value. I change it to something like this, and I plus 1, I'll call it 5 plus 1. And let's say if I choose not to change, then the value remains same, but it will still be inserted into the stack. It will be something like this, and I plus 1 still. But if it is not changeable, but let's say if the values are already perfect, if this is something like these guys, so what will I do? I'll make a check for it, that if I is equals to opening bracket and I plus 1 is equals to a closing bracket, so do nothing and just go for I plus 2 with index. And once I move on to some index, I'll just say that if you get index out of bound, just check whatever is in the stack. Check whatever is in the stack, and if that stack returns a true at any given point, return a true. If it returns a false, return a false. But if at any given point it returns true, as I'm saying that I will return a true, right? True, true. So 1 and 0, return a false or return a true. Okay, let's try to implement this. What all am I having? Let's see. Okay, I'm having a function which will be taking in the value. This will also be taking in the L. Let's just keep this L. LK, maybe LK. Lock. Okay, and let's carry on a stack as well. Let me create a stack of arrows. Let's carry on index. Let's see. Let's carry on an index. If I start from here, I can either change it or not change it, change it or not change it. So if I put it into my stack, it will become something like this guy, something like a closing bracket. Then I can change it. So I can put this. Then I can put this. I can put this and this as well. So let's start from the back as well. Okay. Int I is equals to s dot size. Okay. Size minus one to be precise. And I'm also going to check on. Okay, wait a minute. The locked variable and the size variable is of same sizes, right? Okay, cool. I just have to need to take care of only one index. Let's put that index at the top. I'll just put it here. Now comes the main part, the question. Okay, so I'll be having string s for sure. I'll be having the string locked variable. Again, put it at this. I'll be having a stack. So of character type and it is st, and I'll be passing this as a reference. Pass in a variable I. Now let's see what can I do. What are the possible stuffs that you can do here? I first of all have to check if I is, let's see, if I is equals to if the character, if s of I is equals to a closing bracket and s of I minus 1 is equals to a opening bracket, I do not need to do anything, right? This is my thought process behind it, and I should be always greater than or equals to 0. So checking in the index outer bound conditions as well. So uh, I will say, so now let's call the recursion for slk and st by not putting anything, since I know it is true. Should I not put anything? Why not put anything? If this is equal, why am I not putting anything inside it? I will not put anything inside it. I will indeed push. I will push. Uh, does it make any sense by pushing anything inside it? No, 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 no. I don't think. ST will be fine. And decrease it by I minus 2. I minus 2. So let's see if I have something like dot 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 dot. So these guys are similar. So 1, 2, 3, 4, 5, 6, 7. So if I'm at 7 right now, I'm at 7. I go from 7 to 6 to 5. I go till 5. 7 minus 2 is 5. Okay, okay. That's the time. Minutes. Okay. I minus 2. Move on by I minus 2. Oh, no, not here. Okay, it's already done. Okay, if this is the case, do this thing. Else if, let's see. Can I do next? This is the case where it was similar. And if it is similar, it doesn't matter even if the locked variable is 1 or 0. I won't do it, right? Now let's see if the s of I. Now comes the case when I find that it is changeable or not changeable, right? I find out that if s of I is equals to s of I equals to this or that. Just find out lk. If lk of I variable is equals to 0, that means it is indeed changeable. I can indeed change it. So I can either put uh, changed value, or I can either put a non-changed value inside it, right? So there are two possibilities. So I'll say s dot st dot push. I do it here. Hmm, st dot push and call for that again. Why not do it here only? Let's do it here. St dot push. I'll say if it is a changeable value, right? If it is a changeable value, I need to check first if it what it is. If s of let's say I is equals to uh, closing brace, then I'll put the opening brace inside this stack and again call for the recursion, and again call for the recursion with s comma lk comma st comma I minus 1. I minus 1, let's see. If I call for that, yes indeed I go for I minus 1, cool. But if not, I'll just say st dot push the closing bracket and call for s comma lk comma st comma I minus 1. I did the two possible things, and also I'll coming back. Also, let's pop it out, right? st dot pop st dot pop. Well, I did these things, and I also can choose if it is that push in this, if it is this push in this, or also I can do uh, nothing here, right? I can just leave it as it is if I want to. So this is the part wherein I do that condition, and if the value is just if let's put else if here, if the value of lk of I is equals to 1, the character 1, right? It is the character 1, do nothing. So s comma lk comma st comma I minus 1, just call a recursive call, do nothing. So have I covered all the cases? Okay, now let's see. If I reaches what? If I is equals to 0, should I do it? No. When I is less than the value of 0, then that means yes, I can indeed make a check for the recursion. Indeed, I can make a check for this recursive call. So I have written a recursive function here, 10 to the power 5, 10 to the power 5, 2 to the power n. Oh my god, it is exceeding the bounds. If it is exceeding the bounds, I do not think recursion will suffice here. 2 to the power n. There are many recursive calls which will indeed be made or not made, but since I'm doing so many choices, it could exceed the bounds. Can I do a better job here? Can I do DP? Well, let's just first do a recursive call, then only I can go on to that. And after I'm done doing that, I'll have to make a check for a valid parentheses as well. 15 minutes. God, I just solved one. Whatever. Let's just make a valid parentheses check. Okay. 5 is less than 0. Make a function call for, let's say, check. Hmm, check, which will say bull check, and I'll be passing on the stack here and be just checking if it is indeed possible to make it right. In the parentheses that I have right there are valid enough to check it. So I have taken a stack here. Why do I need a stack? Can I just not take a string? String will also do, right? Why do I need to take a stack here? Okay, let's just say st only. Yeah, so st dot push back st dot pop. Why would I need that? I can just st dot push back st dot pop back st dot push st dot pop. Okay, so this is a string, right? This is a string. Now I can create a stack here for checking it. Okay, this. Now this is a stack right here. Now what can I do? I can just put on check for. See, if I have something like this and I have something like this, what do you say? If I have this, I'll say push in this guy. If I have a closing, push in this guy. If I have a closing, push in this guy again. Now let's see if I have yeah, again I push in opening bracket. Now let's see if I have an opening bracket and I also have I have an opening bracket and I again have an opening bracket deleted, opening delete, opening delete, opening delete. If I am left with nothing at the last in the stack, then I can return a true, otherwise I can return a false. I can do this all as well. Um, for auto in st if s of no, why do I need s? If I is equals to uh, opening bracket, inside it st dot push closing bracket, or why not just say if I have a closing bracket push in a opening bracket, if it is indeed the case. Otherwise, do one thing. Otherwise, go inside a loop and delete all the possible values till you are getting it. If it is not, just go inside it while st dot oh st.top is equals to opening bracket, not st.empty. I can go on popping st.pop right here. Now at last, if I see if I also do not need to return this, I can just return if st.empty. If it is empty, return a true. If not, return a false. If this check returns a true, then I will return a true, otherwise I'll return a false. If I is less than 0, return st. And what else do I have? Only this. Can I also do something like if s.size is if s.size is if s.size, why always go for the index? If s.size exceeds the st.size greater than or equals to, what can I do? I can say I will again return the check of st. And if at any given point this returns a true, then return true. If at any given point if this guy returns a true, return true. Return true. If at any given point this guy returns a true, then return true again. If at any given point this guy also returns a true, then return true. The same thing for this as well. Well, let's hope for the best that it runs. I've written so much. Hope this works. Else if this guy returns a true, return true. Otherwise at last nothing happens and return a false. Well, this is what I came up with. Return, sorry, not true, return whatever it returns as. And st is not a character, it is a string. Well, let's hope for the best. What is it? The time? 6 minutes left. Okay. Let's see if it runs or not. Compile error. Okay. There's a type specifier for all declaration. Type specifier. Okay, bull I have not written right. Function type I did not write. Okay, st dot push. Push. It should be push back. Line number 10. Line number 10. St dot push. What? Stack uses push and pop, right? Remember name push. Was it insert? Was it insert? Stack dot insert. Um, number four. What was the stacks? Okay, stack, push, and pop, right? Stack, push, pop. It was push pop, right? In C++. What was it? Push adds an item in C++. What was the syntax? Do I not remember it or what? Stack, push. What was it? Stack, push, and pop, right? Yes, it is indeed push and pop. So what is the problem? Let's just see here. Stack, it should be push and pop. Stack is the container. Okay, okay. Stack name dot push. Yes, push value. Indeed correct. It is not insert. It is push. So what was the problem? Push a character inside. Okay, sorry. I've given this as a value. Not this should not have been. The stack has been declared as S, not ST. So this will be this, and let's just go on to this guy. Now the stack is empty. That means S is empty, not ST is empty. So that was the mistake that I did. And I was just checking on foolishly that if it is insert or push. What is the problem now? St dot push. Where is it? St dot push. It was somewhere above here. St dot push. St dot pop. St dot empty. Where is it? Where is it? Line number 40. Where is this? Okay, st dot push. Sorry. Okay. Else do this thing st dot push. And now do st dot pop. Wait a minute. If it is indeed inside a bracket, why do I need it again? Right. If it is an else condition and this condition is inside this if I'm closing this, so what is this now? This is the main function. Oh no, I done some blunder here. If it is inside this, so this is the condition of else if. So I've added some extra brackets where it was not needed. This is inside if. This is for the else case. If this returns true, this do this. This should be inside the if as well, and again an else if, and if it returns okay, now it's fine. Let's run this and let's see what the answer is. Expected true. Is it true? Okay, now let's see what I get for the other test cases. It is giving true for all. Okay, now it is wrong. For sure it is wrong. Yep. For every test case it is giving me true, which is not the case. Okay, what does this return? It returns a true or false bool value, right? Okay, what is the time? Okay, we are almost out of time. It is always giving me true, which is a problem. St dot pushback, pop back, and everything that was needed. Return check st. At any given point, if this returns a true, return a true. Otherwise, return a false. Should have been correct, but oh well, I could just do this one right here, and I could not even read the question. Let's just at least read this question. I'll try to absolve these things, these two first. And what is this? Let's read it at least. You are given two positive integers left and right. Okay, with left less than equals to right, calculate the product of all the integers in inclusive range of left and right. Product of all integers in the inclusive range of left and right. Since the product may be very large, you will abbreviate it with following steps. Count all trailing zeros in the product. Oh god. I'll have to read this again. Count all trailing zeros in the product. Okay, trailing zeros in the product and remove them. Okay, whenever I get to trailing zero, I need to remove everything out. Let us denote the count as C. For example, there are three rings, and there are zero trailing zeros in 546. Denote the remaining stuff of the digits in the product as D. If D is greater than 10, okay, what is this? Denote the remaining number of digits in the product as D. Okay, if D is greater than 10, then express the product as the pre and suff, where pre denotes the first five digits. And what if it is less than five digits? First five digits of the product, and suffix denotes the last five digits of the product. Remove all the trailing zeros if D is less than, okay, okay, less than 10. What do? We keep it unchanged. For example, we express this number as 1, 2, 3, 4, 5 and 5, 4, 3, 2, 1. But 1, 2, 3, 4, 5 is representative the same. Okay, when I use the product as string. Okay, I guess we are out of time. And okay, I'll try to do it. Not a problem. I'll have to look more into this problem. Why did this return true every time? Which is not the case. And why did this guy right here? Okay, fine. That's it for this contest right here. And yeah, thank you.